Hello dear children, today's class we are going to discuss about the speed and velocity. We will discuss about the similarities and differences between speed and velocity and the types of speed, types of velocity we discussed. Children, this is second class on kinematics, that is motion in one dimension. In a previous class we discussed about the distance and displacement. So link is given in the description, just go through that video, because if you get an idea about the distance and the displacement, then only you can understand about the speed and velocity, so that you can solve the numericals where distance, displacement, speed, velocity and the types of speed, types of velocity are involved. So it will become very easy to you. Okay, fine. Now without doing delay, let us start about the speed. And before that children, let me tell you one thing. Yes children, and this is our new YouTube channel. So we have one more YouTube channel, it's exclusively for only 9th to 10th, that is a Physics Plaza, and for this channel we named as a Physics Plaza JEE NEET. So in this channel we are going to cover exclusively only class 11th to 12th, JEE mains related topics and NEET related topics, full concepts with the numericals we are going to cover. So if you have not subscribed yet, just it's our humble request to subscribe to our channel, so that you will be getting alerts whenever we upload the videos related to the JEE mains and the NEET. Okay children, fine. So first let us see what actually speed is. Of course we learned about the speed, but just let us have the feel of the concept of speed children. What does it tell? So whenever you are going on a road, if any vehicle crosses you, then what we can say? We can say that, see that how fast the vehicle is going. If not, we can say like this also, hey, go man, just why we are going very slow when compared to that vehicle. Means we'll be talking about the, whenever the objects are in motion, we talk about how fast or how slow that objects are moving. So about that means the speed gives about that only, how whether the object is going fast or slow. This is very important. So speed tells how fast or how slow an objects are moving. Okay, so in a basically the basic definition of speed means generally we can say the distance by time. Of course it is not actually exactly correct. So it is not valid in all cases. Speed is equal to distance by, it won't valid for in all cases. Only in a special case it is valid. Only when a bodies are moving the uniform speed also it validates. Yes, we discuss when we are discussing about the types of speed, you get a command. Okay, till that time, yes, okay, you can say the speed is equal to distance by time. But children, whenever we are talking about the speed of a vehicle, is it compulsory to us to describe about the velocity or describe about the direction? No, it is not compulsory, right? If a person is going a speed, we will tell, see that how fast or how slow the particular person is going. But we no need to tell, right? So here only to describe about the speed of an object, children, magnitude is enough, direction is not required. So already we know about physical quantities which have only what we can say magnitude but not direction. Such a quantities are called scalars. So speed comes under scalar. Speed comes under scalar. And its SI units are, so from this formula we can say that its SI units are meter per second and the CGS units are centimeter per second. And comes with dimension formula. So dimension formula children here, so distance we can say it as a length, so it is L only. So time is T. So L by T. So that is T will go to the numerator. So it will become L T inverse 1. So this also can be expressed like this in a common general way. M0 L T power minus 1. Clear? Fine children. Now let us talk about the types of speed. The first one is uniform speed. Not it is a speed. Okay. Please excuse me. It is a uniform speed. So when you can say that a body is moving with a uniform speed. Children, look at here. So in this example, if you can see, so A to B is 5 kilometers, B to C is 5 kilometers, C to D is 5 kilometers. For suppose here either one object or a vehicle or a person is going. So he is going from A to B, takes 10 seconds time, B to C also 10 seconds time, and C to D also takes a 10 seconds time only. So which means what here, that particular person or the particular object covering equal distances in equal interval of timings. Then we can say that a body is moving with a uniform speed. Children, I repeat, if any object is covering equal distances in an equal interval of timings, then we can say that that body is going with a uniform speed. Is it clear? Fine. But do you think that it is possible in our day-to-day life? So do you think that whenever we are going, just we can go, okay, 1 meter in 1 second, 1 meter in 1 second, like that we measure and we go? So it is not possible, it is. Okay, means I'm talking about, I'm not saying that it is a highly impossible, it is. No, in a very special cases it is possible. Very special cases. So see, uniform circular motion, uniform horizontal circular motion is the best example to say that yes, speed remains constant. So here I repeat once again, children, to describe about speed, only magnitude is enough, direction is not required. So if a body is not, if not uniform, what might happen, children? Yes. So look at here, 3 examples are there. So in a first case, body is covering equal distances, but unequal interval of timings. Interval of timings we are talking. In the second example, body is covering unequal distances, but equal interval of timings. In the third case, children, body is covering unequal distances in an unequal interval of timings. So in these 3 cases, we can say that body is going uniform speed. So either of one is different or 2 are different. Children, please try to understand. In a uniform speed, body is covering with the equal distances in equal interval of timings. Means the distance is covered and the time intervals must be same. Then only you can say that body is going with a uniform speed. If here distances are same, time intervals are different. In the second case, time interval is same but distances are different. In third case, distances and as well as time interval is also different. So in these 3 cases, if any body is going such a, means in either of one situation, then we can say that particular body is going with a non-uniform speed. But children, if any object is going about with a non-uniform speed, but okay, non-uniform speed means yes, it has some speed only, right? But what can we say? So here only we should be very, very, very careful. So if you want a time, if you want a speed in a time interval, or if you want speed of an object at a particular time only, this is very, very important. So if you can understand this small difference, then you can understand the difference between average speed and instantaneous speed. So look at here, children. So if any object is going with a non-uniform speed, children, yes, you can talk about that particular speed of an object in a given time intervals. Means like a 1 o'clock to 3 o'clock, like that you can talk. But whereas if not, you can talk about the speed of an object at that time only we want actually. Yes, see, if I can say like this, you may not understand. Yes, we will discuss in detail, don't worry. First, let us try to concentrate about the average speed. For suppose, children, at a time t1, for suppose the body is at a distance s1, let us say that. So after some time, let us say after time t2, okay na, then the distance covered is s2, okay na. So here in this between time interval, in this between two, it's a time t1, it's a time t2. So there will be some interval right in between this. So in between these 2 time intervals, here what happens? It is covering some distance. Okay, so there will be a change in the distance with respect to the time. As time is changing, there is a change in the distance also. Then how can we calculate about that average speed? Children, whenever you are talking about the average speed, whenever you talk about the speed between the 2 time intervals, then you are talking about the average speed. It is what? Total distance covered by total time taken. So how can we calculate the average speed? What is the total distance calculated? Okay na, by total time taken. Okay, so here S2 minus S1 by T2 minus T1. This is what actually average speed. So the change in distance can be represented. As delta S, and change in time can be represented delta T. So this is what actually average speed, children. So whenever we are talking about the speed, in general it might be average speed only. So total distance traveled by total time taken. Yes, we can take an example, then you get a command. Just till that time, just have some patience. Okay, come to the instantaneous speed, children. Instant means what? At that moment only. At that moment only you want. For example, if you're for example, you are going in a car. If you can see its speedometer, for that instant it might show 60, After some second, it might be 61 or 59. At that moment, the moment when you watch the time and that speedometer, you know, whatever the speed it is showing is what actually instantaneous. Children, when you are talking about the speed of an object, at that time, at a given time, at that instant, at that moment, only we can call it as a instantaneous speed. Instantaneous, right now I want the speed, like that actually. So average speed means what? Okay, let him come. For example, your friend is coming. Okay, you invited your friend for some party actually. So he started like a 2 o'clock. Okay, now after 4 hours he might have reached. Then what actually means, you have enough time, let us say you have enough time. Okay, now then after coming, you know, we can talk, hey, what happened, why you are late, slow, something like that we can talk. But let us take a situation where it is emergency. You ask your friend, just come immediately. He's coming, let us say that. You'll ask, how much time will you take? He'll be telling that, hey, I'm coming fast, slow, or something like that. Then you may ask, hey, what is the speed right now? So right now, the moment when you ask, he says, you know, that time, that speed, that will be the instantaneous speed. Instantaneous speed. Here we talk about the speed between a duration, time duration. Here time duration will be there, but here there is no time duration at that time only. At that time, for example, children, let me tell you. So at a time, let us say at a time, 1 second, just at the moment when we start observing, let us say that the distance, okay, at a initially, let us say that 0 it is starting, let us say that. After, you know, 5 seconds, okay, let us say the distance covered is 10 meters. Okay, now try to decrease the time. So in a 5 seconds, 10 meters means 4 seconds, it might be less than 10 meters only, right? So let us say in a 4 seconds, let us say it's example, just I'm telling you, 8 meters. So 3 seconds, it might be some 6 meters. So 2 seconds, it might be like a 3 meters. In a 1 second, it might be like a some 1.5 meter. Just example I'm telling you. So what if I still decrease the time, let us say 0.5 second. So it might be like a 1 meter. So 0.2 seconds, 2 seconds, it might be like a 0.5 meters. So 0.1 second, it might be like a 0.2 meters, and 0.05 second, it might be 0.05 meters. So just try to, again I'm telling you, so just try to go on decreasing the time. As you are decreasing the time interval, children, what will happen? The distance covered by also decreases. If you make it very, very, very small, almost 0 but not 0. This is very, very important. Very, very important. So I want to know the distance covered by an object in a very, very less interval of time, like a 0.0001 second. It might have covered that moment it has a speed, right? Yes, that speed only we can call it as a instantaneous speed. Means what here? The time duration is almost 0 but not 0, children, but not 0. So here d is delta is by delta t, you know. So here delta t tends to 0. When delta t tends to 0, children, then average speed tends to instantaneous speed. So how can we write? Look at here. So limit delta t tends to 0. So then delta s by delta t can be written as ds by dt. So this only we can call it as a v instantaneous what, children? Speed. So this is what actually rate of change of distance. I think, children, this is the definition we might have learned in a 9th, 10th, 8th classes. So whenever you ask any a student who is studying 9th, 8th, you ask about the speed. What is speed? They will tell that yes, the rate of change of distance is called speed actually. But actually the rate of change of distance is what actually is a instantaneous speed, not a speed. It is a instantaneous speed at that moment. And here one more point I want to tell you. So I have seen some students, so they will be writing delta s ds as a common. Sir, what makes the difference, sir? Delta s is change in speed only, delta s ds also change in speed only. But ds means what, children? Very, very, very small change. Very small change in a very small interval of timings means almost time tends to 0. Almost time tends to 0. Okay, children. So average speed we can calculate between a time intervals. Instantaneous speed we can calculate at a given time. At that moment only we can calculate. Okay. So this ds by dt, this gives you v instantaneous, that is a instantaneous speed. So that is what rate of change of distance. Of course, so this actually this is given by the slope of distance time graphs. Of course, we'll talk about the graphs in detail when we'll be discussing about the ST, VT, AT graphs. Okay, fine. Now, to have a better understanding, let us take a simple example. Children, see, generally we talk about the speed of vehicles. Let us take about the speed of train. So when you can see the train ticket, it might be written like, it's like from where to where you're traveling, the time and everything it is written there. I think it's a speed also mentioned in some cases. So therefore suppose children, you are what we can say let us take it's a Vivekananda Express, so it's a Vivekananda Express. It gives that, for example, is a 180 km per hour. It is given that 180 km per hour. So what does it mean? 180 km per hour means what? Do you think that that particular train covers 180 km per hour actually? No, it is not that. So let us say it is starting from point A, let us say reaches point B. This is the distance it has to cover. Children, first it may start, when it is starting from the station, what is speed ma? 0. So it may have 0 km per hour. Next it might be 20 km per hour. Next it might be 80 km per hour. Next it might be 200 km per hour. Next it might be 190 km per hour. So like this. So the speed keeps on changing in between the stations, right? So then what we do? Yes, the total distance traveled, and we will calculate even the total time taken between these two stations. The total distance what we can travel to by total distance will give you this. So whatever the speed which we are talking is 180 km per hour is average speed. For suppose your friend is in a train, let us say that, just you made a call, let us say that, just you think that he is sitting just beside the driver, it may not be possible, let us say that you call your friend and asked, hey, what is the speed of the train? He might say, yes, 80 km per hour. That moment only he said. So that 80 km per hour is what actually instantaneous speed, that moment. So this might change. In fact, children, average speed is not actually the speed. It gives you a rough idea whether the train or a vehicle is moving fast or slow. Try to understand. So instantaneous speed, at that moment it might be 0 also, instantaneous speed. For suppose some station has come, some red signal is given. There is no what we can say a green signal to go due to some technical issues. Then what happens? The instantaneous speed at that moment it might be 0. But can you say average speed is 0? No, because average speed you have to calculate between these two time intervals. Hope it's clear. Okay, let us take one more example. See, usually we'll be watching a cricket match, right? Okay, I don't know how many of you are watching. Okay, but whenever I get time, definitely I watch mostly World Cups. Now, of course, nowadays these T20s are dominating, right? Okay. For suppose, let us say that, children. So in a first over, so let us say the batsman hit like a 5 runs. Okay. In a second over, for example, 2 runs. Okay, na? And let us say in a third over, so it is like 8 runs. Okay, 8 runs, or else okay. This is, let us take 3 runs, and let us take 4 runs. Let us say only 3 over match. Is it for 3 over match? So you may get on, sir. What is 3 over match? Who knows, in future might get, because test matches became now ODIs. Now ODIs 50 overs. They don't have patience to play. We don't have patience to watch. Became a 20 overs. It became a 10 overs also in some county matches is going. The 10 overs might become 3 overs also. Okay, fine. So now, what is the average run rate? So you'll calculate 4 plus 3 plus 8. By how many hours? 3. How many hours? 3. So this how much, children? So 8 to 11. So 15 by 3. That is what actually 5 runs per over. 5 runs per over. But if you can see these 3 overs, children, first over, second over, second. Did batsman hit 5 runs in a first over? No. Second over, no 5 runs. Third over, no 5 runs. But still, how we got 5 runs? 5 runs per over? Yes. So we have taken the average total runs by total overs. Total overs. For example, if you want the instant runs at that over, it might be 4 runs. That moment only. That over, per that over only, it's a 4 runs. Next it might be 3 runs. Next 8 runs it is. So try to understand, children. So there is a small difference between average speed and instantaneous speed. So average speed, we can calculate the distance traveled between a time intervals. But whereas instantaneous speed means the distance traveled at that moment, means that almost the time interval is almost 0, but not 0. Time can't be 0, right? Very small actually. Clear, children? So this is about the average speed and instantaneous speed. Just make a note of it. Yeah, is it copied, children? 3, 2, 1. Can I raise? Yeah. Yeah, children. So as we have learned about the speed, now the concept of velocity becomes very easy. So now let us learn about the velocity. Just put heading ma velocity. So just let us recall about the speed, children. So speed tells how fast or how slow an object is moving. But velocity, children, is very important. Yes, it also tells how fast or how slow an object is moving, and also tells where it is moving, in which direction it is moving, where, which side, which means what? Direction also. Very important. So this is about the magnitude. It is all about the magnitude plus direction. So velocity gives you information how fast or how slow an object is moving, and also in which direction it is going. This is very important, children. So here one important point is there. So either a displacement or a velocity which gives the direction of motion of an object. Children, what is your answer? Let me repeat my question. So displacement, velocity, out of these two, which gives the direction of motion? Is it displacement or velocity, children? What is your answer? Come on, think. Just pause the video, just think and comment your answer. Is it displacement or a velocity gives the direction of motion of an object? Okay, try it. Children, look at here. Let me tell you. For example, children, let us take a index line, number line. Let us take a number line, children. Okay. Let us take the origin. It is the origin. So this is, we know that it is a positive x-axis. It is a negative x-axis. Let us take the 1, 2, 3, 4. Here it is -1, -2, some -3, like this. For example, children, here the person is standing, let us say. For example, his displacement, I can say that is a 2 meters. Now just with this information, I can say that the person is standing at 2 meters from the origin on positive x-axis side. Or if somebody says that yes, displacement is -2 meters. For displacement -2 meters, then we can say that the person is standing on negative x-axis at a distance of 2 meters from the origin. But can you say whether this person can move right side or left side? Can you say in which direction the person can move? No, we are not sure. This person can move right side or left side. We are not sure. But whereas if it is given, for example, the velocity of the person is +2 meter per second, which means that the person is covering 2 meters per second in a positive x-axis direction. If somebody says that the velocity of the person is -2 meter per second, which means that the person is covering 2 meters per second along the negative x-axis. So which means what? It is the velocity which gives the direction of motion of an object but not displacement. So displacement tells you exactly where the person is standing. So for example, I am standing here. Children, for example, let us say that with respect to let us say my cupboard, let us say it's a 2 meters distance, let us say that. Now just somebody says that yes, that is displaced from the cupboard 2 meters. Now can you say whether I move right side or left side? Are you sure? No, you can't. You are not. You are not. It's not possible. So displacement does won't give you the direction of motion of an object, and it is a velocity gives the direction of motion of an object. This point is very important. Clear? Fine, children. Now, so velocity actually, yes, it gives you information about how fast or how slow an object is moving, and in which direction also it gives that sense. The sense of direction also is given. Okay, fine. Now, so in the simple terms, velocity is equal to, as we have written for speed, let us write for this also, displacement by time. Children, again I am telling you, this is not a common, you can't use this formula in all the cases, only in a special cases, only when the body is going with a uniform motion only you can use velocity is equal to displacement by time actually. Children, as velocity has even direction, yes, children, it's a velocity is a vector quantity because it has a magnitude and as well as a direction, it also obeys the vector law of addition. And children, it is a dimension formula. Dimension formula is similar to the dimension formula of speed, that is L t power minus 1. Children, it's one important point here. Speed might be a scalar, speed might not might be, it's a scalar and velocity vector. So both might be different physical quantities, but they have same units and same dimension formula. It's very important. So speed is a scalar, velocity vector, but still their units and their dimension formulas are same. Okay, fine. So it is a vector dimension formula. Now children here, so let us talk about the uniform velocity types. Uniform velocity, similar children, uniform velocity. So what is the uniform velocity, children? Yes, if a body is covering equal displacements in an equal interval of timings, means what? You have to talk about the direction also. So for suppose, so let us say like this. So it is a A, B, C, D. So this is 5 kilometers. Let us say it is a 5 kilometers. It is 5 kilometers. So it is just direction. Uniform velocity or uniform motion we can say, children. So it is covering 5 kilometers in a 10 seconds, 5 kilometers in a 10 seconds, 5 kilometers in a 10 seconds. So equal displacements in equal interval of timings. Then we can say that body is moving with a uniform velocity. It also called as uniform motion. It is covering equal displacements. When I say displacement in a particular direction, because displacement is a vector quantity. Okay, fine. If not, children, if not, for example, yes, straight line only. For example, straight line only. Let us see that. So here is A, B, C, D. Let us see that. So it is a 5 kilometer, 5 kilometer and 5 kilometer. But here is 10 seconds, 2 seconds, 7 seconds. Means what? Equal displacements but in an unequal interval of timings. So let us take one more case, children. Yes, so it is a A to B, C, D. Let us say it's a 2 kilometers, 5 kilometers, 7 kilometers. Means what? Unequal displacements in an equal interval of timings. For suppose 10 seconds, 10 seconds, 10 seconds. And third case also, what is the third case? Unequal displacements in unequal interval of timings. In these three cases, we can say that body is moving with a non-uniform. Means either of one. Here you may get a one doubt. Sir, in these three cases, there is a change in a magnitude, but there is no change in direction. Yes, children. See, when you can say that velocity is a non-uniform or it's a velocity variable, children, either magnitude is changing or if a direction also changes. If direction changing, magnitude is not changing, but direction is changing. In that case also, you can say that body is moving with a non-uniform. Okay, so when you are talking about the non-uniform speed, it's a non-uniform velocity. So are you talking about the velocity in a given interval of timings? Or are you talking about the velocity at a given instant? Yes. So now we are going to talk about the average, what we can say, average velocity. Average velocity. So average velocity, how can we say that? Yes. So this is a total displacement. Total displacement covered by total time taken. total time taken, children. So this can be written as, let us say, S2 minus S1 by it is T2 minus T1. We also can express average velocity is equal to delta S by delta T. So this gives you what, children? Average velocity. Average velocity. And what about instantaneous velocity, children? Instantaneous means the velocity of an object at that moment, at that time only. So instantaneous velocity, children, as we discussed, instantaneous speed, everything is same, but the thing is that here we consider the direction. So here when delta t tends to 0, when the time intervals are very, very, very small, approaching 0 but not 0, so then we can write velocity. So it is the instantaneous velocity can be written as limit delta t tends to 0, that is delta s by delta t. This can be written as ds by dt. Children, this only we can call it as a rate of change of displacement. Not this, you cannot say this, you cannot say that. Actually, this is what actually rate of change of displacement gives you instantaneous velocity. Children, this is nothing but the slope of displacement time graph. Displacement time graph gives you rate of change of displacement. This is called as instantaneous velocity. Is called as instantaneous velocity. Children, just you copy this. Just now we'll see few important points related to the average velocity, average speed, and instantaneous velocity. Just copy this first. So copy it. 3, 2, 1, go. What can you say about average speed? Children, these are a few important points. Of course, these points are easy only, but sometimes we get confused. Let us see first point, children. So see here, children, we are using what we get symbols here. Children, when I say V is a speed, so when I am writing here above bar, so it is a velocity, that you should understand. Okay, na? So otherwise, again there will be confusion. Fine. So children, for suppose children, here you are at a point A, let us say point B. So let us say from here to here, let us say 5 kilometers. So when you go from A to B, without changing the direction, if you are going, yes, your speed is equal to velocity, no problem. It's not a problem at all. But for suppose if you are going like this, for suppose you went like this some other day, you went between A to B, you went like this, it might be a 10 kilometers. But children, so in a second case, what will happen? Speed will change. Speed changes, right? Speed changes, because if for example, let us say that you have to cover 5 kilometers and 10 kilometers in the same time, let us say that, then obviously here you have to move fast manner. So there is a change. So your speed is less. Here in second path, your speed should be more if you want to reach in the same time. But what can you say about the velocity? Still the velocity you can take like A to B only, because velocity is, it's all about the change in displacement. So displacement is what actually initial point and the final point. So speed depends on the path taken, but whereas velocity does not depend on the path taken, it just purely depends on the initial point and the final point. Clear? Fine. So next one, children, at a given time, instantaneous speed is equal to the instantaneous velocity, of course. So at that moment, even you don't have a time to change the direction also. At that moment only, just almost time interval is 0. At that moment, yes, the speed and the velocity, yes, that moment I'm talking. If you just take some more time, it is different actually. At a given time, yes, instantaneous speed is equal to the instantaneous velocity. Fine. Next, children, here. So a body is moving without changing the direction. Yes, as I told you in the first case, for example, body is going along a straight line path, but the direction, it is not coming back. Yes. So in this case, so whenever a bodies are going along a straight line path and their directions are not changed, so in that case, children, yes, you can say speed is equal to velocity. that is average speed is equal to average velocity, because as it is going along a straight line path, children, there is no point in talking about the direction, because there won't be any change in direction. The body is going along a straight line path, it is not coming back, children, it is not coming back. So without changing direction it is going, then average speed is equal to the average velocity. Yes, and here you can see few really important things here, children. So if a velocity is a constant, what can you say about the speed? See, first here, velocity means, children, yes, it talks about the magnitude and direction, right? Direction. But here by requires only magnitude but no direction. So if a velocity of an object is a constant means, by default speed must be constant. Speed must be constant. And if speed is a constant, what can you say about the velocity? No, we can't say that velocity must be a constant, children, because speed talks about the magnitude only, we are not sure about the direction. So if a speed remains constant, velocity may or may not. The best example for this, children, uniform circular motion. So if you can say here uniform circular motion, the body is going along a circular path, children. Body is going circular path. Let us say that at this point its speed is 20 meter per second, and here also let us say that 20 meter per second, and here also let us say 20 meter per second, and here also 20 meter per second. Yes, so in this speed remains constant, but every point, children, the direction of velocity keeps on changing. So in this case, children, yes, the speed is uniform but not velocity. So here, if speed is a constant, yes, velocity may or may not be constant. You may get one doubt, sir, in which case velocity may be constant. Yes, if a body is going along a straight line path, speed remains constant, velocity also remains constant. But whereas a body is going along a circular path, children, speed remains constant but not velocity. Why? Because its direction keeps on changing. Clear? Fine. Now, if v is a variable, that is velocity is a variable, what can you say about speed, children? Speed, what can you say about the speed? Can you see that because velocity is a variable, speed also must be? No, may not be. Because when you can say that velocity variable, either magnitude is changing or magnitude is not changing but direction is changing, still you can say that velocity is a variable only. So here, if velocity is variable, you can't say that speed must be variable only. No, it may or may not be. If a speed is variable means, children, speed means what? Speed talks about the direction. Speed talks about the magnitude. If magnitude only changing, velocity changes at any cost. If speed is a variable, velocity must be variable only. Velocity, there is no doubt. So, velocity must be variable, children. Velocity must be variable. Fine. If average velocity is 0, what can you say about the average speed? For suppose, children, here at a point A, so body moves upward direction, h, again just comes back, h only. Okay, now, so in this case, distance covered is 2h, but displacement covered is how much, children? Displacement is 0. Why? The body is coming to the same point. Initial and final point, what coincides here. So in this case, displacement is 0. Obviously, average velocity is 0. But average speed is not 0. Why? Distance has some value, right? So the distance 2h by time taken, if you can calculate, you will get the average speed. So here, children, if average velocity is 0, you cannot say that average speed also must be constant only. No, it may or may not. You may get one doubt, sir, in which case average velocity may 0, sir. Body is at rest. If body is at rest, there is no distance covered only. As there is no distance, there is no average speed only. Clear? Yes. So it may or may not. But if average speed is 0, average speed is 0 means what, children? Body must be at rest only. Then average velocity must be 0. There is no question, there is no point in talking only. So if average speed is 0, average velocity must be 0. But if average velocity is 0, average speed may or may not 0. So children, so these are some important points regarding this average speed and average velocity. Just make a note of it. Just we do one or two, it's like it's a numerical type, like which we are going to derive two formulas. Of course, it comes under numericals also. Just copy this. We'll do that. V2. Children, here look at here. So here are two situations. In the first case, children, try to understand. So between A and C, okay, now the total distance is S. Let us say that. So it is given that, children. So a body is moving such a way that first half distance, first half distance it is going with the V1 speed, and the second half distance it is covering with the V2 speed. Okay, now then what is the average speed in this case? Whereas in the second case, first half time with the speed V1, second half time with the speed V2. Children, you should what we can observe this difference here. First half distance, second half distance. Here first half time, second half time. In both cases, we need to calculate the average speed. Children, average speed means what actually? We know the total distance traveled by total time taken. There's a common formula. So children, V average is equal to total distance traveled. Total distance traveled by total time taken. Children, but here time is not given, but we know that speed is equal to distance by time. From this, children, time is equal to distance by speed. So from A to B, children, let us say that from A to B, so the speed is V1, the time let it is a T1, so this will be distance is S by 2 by it is a V1, so this will be S by 2 V1. So same thing from B to C also. What is the time taken from B to C, children? Distance traveled is S by 2, speed is V2, so this will be S by 2 V2. Now, so V average, so we need an average speed, children. Average speed is equal to total distance traveled. Total distance is how much? S, so it is S by total time taken, T1 plus T2, T1 plus T2, so this can be S by, this is S by 2V1 plus S by 2V2. So children, here you can take S as a common, so this will be S by, S if you can take 1 by 2V1 plus 1 by 2V2. Here S gets cancelled in the denominator, so you can just see LCM here. 1 by 2 is a common, right? So this will be V1 plus V2 by 2V1 V2. So this will go to the numerator. So here average speed is equal to 2V1 V2 by V1 plus V2. Children, this formula we use to calculate the average speed when if a body is covering first half with some speed and the second half with some other speed. But come to this second situation. Here situation is different. First half time, second half time. Now what is the distance covered from A to B, children? A to B. So distance is equal to speed into time. So let us say A to B, it is a S1. So speed into time, that is V1T by 2. Similarly from B to C, it is S2 is equal to V2 into T, children. V2 into T. Now let us calculate the average speed. So V average is equal to total distance S1 plus S2 by total time taken. Total time taken is T only, right? Yes. So S1 you substitute here, V1T by 2 plus V2T by 2 by it is T. So here in a numerator you can take a T as a common, children. So this will be V1 plus V2 anyhow by 2 because LCM is a common by T. T gets cancelled. So here V average is equal to V1 plus V2 by 2. Children, Look at here. In both cases, we are calculating the average speed only. In both cases, we are calculating the average speed only. But different results we got. Why? Situations are different. Seems to be same. But you should notice here. This is first half time, second half time. Same it is. Here, first half distance, second half distance. But here, first half time, second half time. Clear, children? So this is very important. This is average speed. For suppose, children, of course, if a body is going along a straight line path, yes, average speed is equal to average velocity. Same, it is a average velocity also. But you may get a wonder, sir, what if a body, for suppose, look at here. So from A to B, body is going S distance. Again, it is coming back B to A. So A to B, it is going with a V1 speed or V1 velocity, or B to A, it is coming with a V2 speed or a V2 velocity. Then what is the average speed? Yes, average velocity, average speed is 2V1 V2 by V1 plus V2 only. But what is average velocity? In that case, average velocity will become 0. Why? The body is coming back to the same point. Total displacement is 0. Hence, what is the average velocity? 0 only. Okay, children, just copy this. We see one more case, and after that we can end this session. Okay, copy this. Let's take time t. So children, as per the question, children, here a particle is in motion such that first half of the distance it is covering with the speed v1. In the second half of the distance, in 1/3 of time going with the speed v2. In a 2/3 of time it is going with the speed v3. Then what is its average speed? Children, this seems a bit confused. But if you can just divide into parts and if you can see, that will be very easy as to solve. It's very easy to us to solve actually. Look at here, children. First, so here if from A to B is a D, means obviously from here to here also the total distance is D only, right? Second half distance must be equal. So BC plus CD. BC plus CD is equal D. But BC, this distance we don't know. But we know the formula, right? Speed into time gives BC distance. Okay, now this speed into this time distance CD. So that is what it is written, BC and CD. So this distance we got actually. Now children, average speed. So average speed is equal to, we know that total distance by total time taken. So total distance is what? D plus D. That is D plus D by total time taken. Let the time taken from here to here is T AB plus here to here T BC plus here to here T CD. But this total time is T, right? The total time taken B to D is a T only. Okay, from this to D by. Children, how to get the time taken here? Yes, we know that here speed is equal to distance by time. So time is equal to distance by speed. So distance is, it is D by it is V1 plus time is T. But how to know this time T, children? Yes, from here you can calculate. So from this, children, you substitute BC place, you can substitute this term, CD place, you can substitute this term. Then it will be TV2 by 3 plus 2TV3 by 3 is equal to D. So 3 is LCM common, will go this side. So it is going to be here, you can take a T as a common. So T is equal to V2 plus 2V3 is equal to 3D. From this, T is equal to 3D by V2 plus 2V3. Now this T value you can substitute here, children. So then what do you get here? 2D by D by V1 plus 3D by V2 plus 2V3. V2 plus 2V3. So now in this denominator you can take a D as a common. And this D and this D will get cancelled. So this will be 2 by 1 by V1 plus 3 by V2 plus 2V3. Here you can take a LCM, children. So this is going to be 2 by 3V1, this term I am writing first, plus V2 plus 2V3 by this, whatever the term it will be there, you write here LCM, that is V2 plus 2V3. Now this term will go to the numerator. So from this we can write average speed is equal to 2V1 by V2 plus 2V3 by 3V1 plus V2 plus 2V3. So this is how actually we can calculate the average speed. So children, so this is actually today's discussion about the speed, velocity and average speed. Okay children, thank you so much. All the very best.